linear functions. Now, what is a linear function? We have seen this already in my examples. Y equals x plus 1 is a linear function. So when we graph a linear function, it is going to look like a line, hence the name linear. So line, linear. So y equals x plus 1. We graphed it earlier today. And that is simply a line. And you can see that this line is sloping at an angle. So the reason for that is that the slope of this linear function is 1. How do we recognize the slope? And what do we call this number that's right here, this 1? That is the place where the line crosses the y-axis. So the line, or the function y equals x plus 1, crosses the y-axis at y equals 1. And that is the exact same one you see there. So that is the y-intercept. And I mentioned that the slope is 1. So 1 times x is still x. That number 1 is simply the slope. That is going to determine in what way the line's going to slope. Either it's going to lay flat, or it's going to be fully vertical, or it's going to be partially at an angle, and so forth. Let's see. Suppose I draw a line . That dotted line in red. Do you believe that that line would have a slope bigger than y equals x plus 1, or would it be smaller than y equals x plus 1? You can type in chat. I'll give you a few seconds. Okay, most of you gave me the answer as bigger. So it sort of is going that way. So the slope is getting bigger and bigger. An easier way to understand this is if something lays flat, think about a ladder laying flat on the ground. If we have a flat line, that line has no slope at all. Let me just say that's -5, and we have y equals -5. And if your line is getting closer and closer, or becoming more and more parallel to the x-axis or to this line, then the slope is decreasing. If it goes farther and farther from the x-axis and becomes parallel to y, then the slope would actually be getting bigger. So let us start with the function y equals 3x plus 9. Or let's start small. Let's do 3x plus 1. This is a line because it looks very much like x plus 1, only this time have multiplied x by 3, and the y-intercept is 1. So when I graph this, that is the line I am guessing, and for y equals 3x plus 1. If you can't see the y-intercept exactly, we can adjust the window between, say, -3 and +3. Adjust the window from -5 to +5. And you can see a clearer picture. And you can see that the line crosses the y-axis exactly at 1. So we looked at y equals 3x plus 1, and based on what I wrote earlier, that 3 would be the slope and 1 would be the y-intercept. Now, I am going to change the 3 to a negative 3 and have x as is and put plus 2. So in this case, the y-intercept is 2 and the slope is negative 3. If the slope is negative, then the line would be going in the other direction. In other words, it would be decreasing. Let's see if that happens. That is the first line. Now we drew the second line, and you can see that the second line goes down, it's decreasing, and the first line is increasing. You can also notice that the y-intercept of the second line is at 2, right over there, slightly about that center of x. And you should also observe that the lines cross the x-axis as well. That's okay, Calvin. So they cross the x-axis also, and the points where the line crosses the x-axis are called the x-intercept, just like the points where the line crosses the y-axis is called y-intercept. The point where the line crosses the x-axis would be called the x-intercept. For a linear function, it is quite easy to look at the equation and say, oh, the slope is 1 and the slope is 3 and so forth. But there are other functions where it's going to get trickier to determine, okay, where is the slope on this interval, or even determine the y-intercept. So how do we find the x and y-intercept if we do not know what a linear function looks like, if we have a function that is not linear? In short, x-intercept is the point where y is 0. Y-intercept is the point where x is 0. And I showed you 2 different curves using the calculator, which is right over there. And one of them is 3x plus 1. The other is negative 3x plus 2. Of course, we know the y-intercept and slope already because it's a linear function. Now, I want to use some algebra and see if I could come up with those values. So let's consider y equals 3x plus 1. And y equals negative 3x plus 2. So x-intercept. So x-intercept is the point, to be very precise, is the value of x, where y is 0. Y-intercept is the value of y, where x is 0. So to find the x-intercept, all I have to do is set y to be 0. Then you solve for x. So I move that 1 to the other side or subtract by -1 on both sides. So -1 would equal to 3x. I would like to solve for x, so I divide by 3 on both sides. So -1/3 would be x. So this would simply mean the x-intercept is -1/3 for the line 3x plus 1. And we could also represent this as a coordinate pair, which is x comma y. So we have -1/3, that is the x value. The y value is 0 because we are trying to find the x-intercept, and at the x-intercept, the y value is 0. How do we find the y-intercept? All we have to do is set x to 0 and solve for y. So we have y equals 3x plus 1. That would equal to 3 times 0 plus 1, which is 0 plus 1, you get 1. So, which would mean that the y-intercept is 1. And as a coordinate pair, the y value is 1 and the x value is 0. So these two are one and the same. One gives you just the y value, the other gives you a coordinate pair. So if you want to find the x-intercept, we set y equals 0. If you want to find the y-intercept, we set x is equal to 0, and we solve for the other variable. So x-intercept, same process. We set the value of y to be 0. And we solve for x. I'll move the positive 2 to the other side. It would become -2. Divide by -3 on both sides. The negatives will go away, and you'll have x to be 2/3. That is just the x value. But if you want to write it as a coordinate pair, you could write it as 2/3, which is the x value, and 0 is the y value, because the value of y is always 0 at the x-intercept. Y-intercept, we just have to set x is equal to 0. So -3 times 0 plus 2, which gives us 2. So that is just the y-intercept as a value for y. If you want to write it in a coordinate pair or as a coordinate pair, you can write it as 0, 2, because the value of x is always 0 at the y-intercept. So I'm going to show you how to verify our answers using the calculator. There is a nice little function called trace. So let's do one by one. So I'm going to use the first equation, and that's what I have. And the trace button is this second button on the right, top right. So press trace, you'll have a cursor. And right now the cursor is exactly at the y-intercept of the line. And you can see at the bottom of the screen, the value of x is 0 and the value of y is 1. As a coordinate pair, it is 0, 1. And that is the answer we had over here, 0, 1. If we want to find the x-intercept, we move the cursor. You can use the arrow keys. The up and down is going to move the cursor up or down. And the right and left arrows would move the cursor right side or to the left. So as I move to the left, so that's where I am at. And you can see that the X-intercept doesn't seem to sort of match what we have over here. The reason for that is it's only giving you an estimated value. It is not giving you the exact value. We can make it more exact. And if we did make it more exact, we will see that the value is actually negative 0.32. The X value is negative 0.32. The corresponding Y value is 0.04. If you approximate it, it's very close to negative 1/3, which is negative 0.33, and 0.04 is close to 0. There are ways to find the accurate answer using the calculator, but I don't want to introduce it at this point in time. Later on, we will talk about it and I'll show you how. I don't want to overload you with too much information. Now we can move on to the second linear equation, negative 3x plus 2 graph, and trace again. And by default, it goes to the intercept. And the intercept is x is equal to 0, y equals 2. As a coordinate pair, it is at the point 0, 2. If I move the cursor right, bit by bit, I sort of get there, and the value is 0.6382 and 0.0851. 0.08 is sort of close to 0, so we'll call it 0. And 0.638 is a bit far away from the actual answer, which is 2/3. 2/3 is 0.67. Once again, the calculator is doing an approximation for the X-intercept. The Y-intercept is easy. The calculator, right away, it'll go to the Y-intercept. But the X-intercept requires a bit of work, just like us. And the calculator, as of now, is giving you an estimated value and not the exact value. There are ways to find the exact value using this calculator, but I'll save it for another time.